Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 6 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2965. Find missing and repeated values. Okay, so let's read the problem statement first. You are given a zero indexed 2D integer matrix grid of size n into n with values in the range 1 to n square. Okay. Each integer appears exactly once except a, which appears twice, and b, which is missing. Okay. The task is to find the repeating and missing numbers a and b. We have to return a zero indexed integer array answer of size 2, where answer of 0 equals to a and answer of 1 equals to b. Okay. And b is the missing number and a is the number which appears twice. Okay. So now see this example number 1 here. So this is my grid, right? So here what is the size of grid? Grid size is 2, right? 2 rows and 2 columns. Okay. So we have same number of columns and the rows, right? N into n. So we have elements from 1 to n square. Okay. So n is 2, right? So we have numbers from 1 to n square. That simply means 1, 2, 3 and 4. Okay. So now here if you go over this grid, so we have 1, we have 3 and we have 2 2 times. Okay. So 2 is appearing 2 times. So that simply means that this is going to be my a. Okay. So a which appears twice and this 4 doesn't appear here, right? So this is going to be my b. Okay. So we are returning one output array in which first we are writing the number which is appearing twice, so 2, and the number which is missing, this. Okay. So this is what we need to do, right? So I'm going to solve this problem using 3 approaches. So approach 1 and approach 2 is very simple, right? Approach 3, there is some mathematics that we are going to use, so I will explain that in detail. Okay. But first let's see how we are going to solve this problem using approach 1. So in approach 1, what I will do, I will create one set. Okay. And in the set I will just iterate over all the elements one by one, and in the set I will add the elements one by one. So here first one, so in the set I'm going to add one, and then next element is 3, I'm going to add this in set, and the next element is 2, I'm going to add this in my set. And then when I reach here I see that this 2 is already there in my set. Okay. So that simply means that this number is appearing twice, so in the first position I am going to write this 2. Okay. And that's it. Now after that again I'm going to run one loop from 1 to n square. Okay. We have numbers from 1 to 4, right? And now here I will check what are the numbers which are there in my set or not. So 1 is there in my set, 2 is there in set, 3 is there in set, and when I search for 4, 4 is not there in my set. So that simply means that 4 is missing. Okay. So this is going to be approach 1, very simple. So here this code, this is the code for approach 1. Okay. So calculating the length and creating one set and the result. Okay. So size is 2 only, right? We have to add the number which is appearing twice and the missing number here. Then I'm running one loop, and here I'm just adding all the elements in the set, and if my set already contains that one particular element, then that is going to be my result of 0. Okay. So I'm adding the number which is appearing twice here, and then again I'm running one loop from 1 to n square, because we have numbers from 1 to n square, and I'm checking the set if this is there in my set or not. So if it is not there, I'm adding that in my result. Okay. And once I found this missing number, I'm just breaking this. Okay. And then I'm returning the result. Okay. So this submission is accepted, right? Okay. Done. So here time complexity is going to be of n square. Okay. So we are running these two loops, right? N times and this n times. Okay. So n square is going to time complexity for this one, and here we are running until n square, so of n square plus until n. So overall you can say of n square is the time complexity. Okay. So here we are just running till the number of elements. So here if you see this problem, I think constant size is very small. Okay. So only 50, right? All right. So this is done. This is approach 1. Okay. Now in the approach 2, you can also use the frequency mapping hash map, right? So here what I'm doing, I'm calculating the length of the grid, and here I'm setting the missing to -1 and the repeat to -1. Then I'm going to store the frequency of each number in the hash map. Okay. So I'm iterating over all the rows, and I'm iterating over all the numbers in that particular row. Okay. And I'm just going to calculate the frequency. Like here if you see, 1 is appearing one time, 3 is appearing one time, 2 is appearing two times. Okay. So this is what I'm going to do. Okay. And then I'm just going to uh, Once this is done, then after that I'm going to check the numbers from 1 to n square to find the missing and repeated values. So here, if my this frequency map doesn't contain any number, that simply means that that number is not present in that grid. Okay, so I'm going to add that number here which is missing. Okay, at this position. And as if the frequency of any number is 2, that simply means that I got this number. Okay, so in the end I'm just returning this array. Okay, so this is approach 2. Okay, it's very simple, both are similar only. Okay, so, but just a little bit changes. Okay, so here we are using set, here we are using mapping, hash map. Okay, so now let's come to the approach 3. Okay, so here I will explain what we are doing. Okay, we are not going to use this hash map or set. Okay, we are, without using this, we are going to solve this problem. Okay, so this is going to be my approach 3 using math. Okay, so here first thing, just tell me if I have numbers from like this 1 2 3, and I told you guys to calculate the sum of these, sum of first 3 natural numbers, then there is one formula, right? N into n plus 1 divided by 2. This is a formula, right? Sum, this is the formula to calculate the sum of the first 3 natural numbers or first n natural numbers. Okay, that is why I'm writing n. Okay, so here in this example I want to calculate the sum of first 3 natural numbers. So here just apply in place of n, just write 3. 3 plus 1 is 4 divided by 2, so I'm getting 6 as output. So yes, this is right now. 1 plus 2 is 3, 3 plus 3 is 6. Okay, now same way, if I ask you guys to calculate the sum of the square of first n natural numbers, then there is one more formula, that is n into n plus 1 2 n plus 1 plus 1 divided by 6. Okay, so these are the formulas. Okay, I think we have studied these in class 8th or 9th, right? These formulas. So there is one chapter like AP GP series in that, right? So here, this is the formula to calculate the sum of the square of first 10 natural numbers. That simply means 1 square plus 2 square plus 3 square. Okay, right? So let's say I want to calculate the sum of this. Okay, so here if you calculate it manually, you are going to get 1 plus 2 square is 4, 4 and 3 square is 9, so that simply means 14. Okay, now just apply this formula, 3. Okay, first sum of square of first 3 natural numbers, so just write 3 here. 3 plus 1 is 4, and here 3 into 2 is 6 plus 1 7, and here we have 3, we have 6. Okay, 3 1, and it is going to cancel this 2 here, and this is going to cancel 8. So in the top we are going to get 1 into 2 into 7, which is 14. Okay, so that simply means this formula is right. Okay, so this is for sum of first n natural number, this is sum of square of first n natural number. Okay, so now in our problem, okay, in our problem we have numbers from 1 to n square, so I'm just going to change this n to n square everywhere. Okay, so here I'm going to change it as n square plus 1 divided by 2. Okay, this formula I change n to n square. Okay, and here same way this formula I can change it to n square plus 1, and here I can change it to 2n square plus 1, 2n square plus 1, and here I can change it divided by 6. Okay, that's it. So this is the sum of first n square numbers. Okay, this you can write. Okay, and here is the sum of first n square numbers. Okay, so actually this is a summation of n only, but here we are treating n as n square. Now this is a summation of n square, but here we are treating n as n square. Okay, that is why I'm writing it like this. Okay, so this is clear, right? Until here it is clear. All right, so now here we are expecting numbers from 1 to n square, right? So I'm expecting all the numbers. Okay, let's suppose if all the numbers are there, 1 2 3 4. Okay, so in that case what is going to be the my perfect sum? Okay, so here n is 2 in that case. Okay, so I'm going to calculate the perfect sum. Okay, so let's say this is nothing but my perfect sum. Okay, and this is nothing but my perfect square sum. Okay, so here in my example we have n is 2. Okay, so here if I apply this formula, okay, so 2 square, that is nothing but 4, 2 square plus 1 5 divided by 2, so I will get my perfect square as 10. Okay, if we have numbers from 1 to 4 here. Okay, there is no number which is appearing twice, and there is no number which is missing. Okay, we have all the numbers 1 2 3 4. So if you do the sum, you will get 10 only. Okay, so 1 plus 2 plus 3 plus 4, you are going to get 10 only. Okay, so this is a perfect sum. Okay, so if I do the square of this 1 square plus 2 square plus 3 square plus 4 square, then what is the result that I'm going to get? Okay, so then in that case 4 square 16, 16 plus 9, then here 4 plus 1, we are going to get, I think, 30, right? Let me just calculate. 16, 16, 20, 21, and okay, 30. Okay, so we are going to get then this perfect square sum as 30. Okay, so this is done, right? So sum of first n square numbers, right? Done. Okay, so now here uh, I can but here if you see in this problem, what is the sum that I'm getting? I'm getting my sum as 1 uh, plus 3 4 4 5 6 7 8. Okay, I'm getting sum as 8, but my perfect sum is 6. Okay, my perfect sum is 10. Okay, my perfect sum is 10, but I'm getting my sum as 8. Okay, see here, this is my perfect sum. Okay, here I have calculated perfect sum for this particular example. Okay, right, 10, but my sum is coming as 8. Okay, so now here can I write here one thing? Let's say that x x is the repeating number. Okay, let's say x is the repeating number, and you can say missing number as y is missing number. Okay, x is the repeating number, y is the missing number. So here I can write it like this. Okay, I can write this equation like this: sum uh, is equal to the perfect sum, and in the perfect sum, if I add the x, okay, x is nothing but a repeating number, and then subtract y. Okay, can I write it like this? Okay, I can. Let me prove. So sum is 8. Okay, your perfect sum is 10. In 10, if you add x is a repeating number, so in this example, but it's a repeating number 2. Okay, and what is the missing number in this example? Missing number is 4. So 10 plus 2 minus 4, so here 8, and in this side 10 plus 2 12, 12 minus 4 8. Okay, so LHS is equal to RHS. So I can write this. Okay, I can write this equation: sum is equal to perfect sum plus x minus y. Okay, done. Okay, so now after that, so here, okay, so now here sum minus perfect sum. Okay, if I do sum and perfect sum is difference. Okay, so what is the output that I'm going to get? So here let's say sum difference. So it is going to be x minus y. Okay, so if we compute the sum of numbers in our grid sum and compare it with the perfect sum, we can express their relationship as sum difference, okay, is equal to x minus y, right? So this tells us that the difference between the actual sum and the perfect sum. Okay, so actual sum and the perfect sum, so this is a difference. Okay, x minus y. Okay, now if we compute the sum of squares from our grid, okay, that is a square sum, and compare it with the perfect square sum, then what we are going to get? Okay, so square difference, this is sum difference. Now if I write square difference, so square difference definitely it is going to be x square minus y square. Okay, this is the formula that I will write. Okay, so sum is going to be, I can write it as perfect sum plus x minus y. So if I take my if I calculate the difference between the actual sum, that is this sum, minus perfect sum, so I will get x minus y. So this is a sum, this is just a normal difference. Okay, but if I want the square difference, so that is going to be x square minus y square. Okay, now here we have this, I can write this x square minus y square as, this is also mathematical formula, I can write it as x minus y and x plus y. Okay, so here also one more thing, sum is 8, or you can say actual sum or just sum, and also actual square sum. Okay, square sum you can say is going to be 1 square plus 3 square, that is 9. 9 plus 1, 10. 10, 14, 18. 18 is coming. Okay, actual square sum is coming as 18. Okay, and sum is coming as 8. Okay, so here I let me write sum is 8, square sum is uh, 18, and here perfect square sum it is coming as 30. Okay, let me write it like this. Okay, so this is what we know already, right? And here we had write one formula, right? So actual sum minus perfect sum is x minus y, so this is sum difference, and square difference is always going to then x square minus y square. Okay, so we can write it like this. Okay, now here we can write, since we already know x minus y is nothing but sum difference. So here I can write square difference as equal to x minus y. We already know that it is sum difference, and here x plus y. Okay, this is clear until here, it's clear, right? So now here or I can write my x plus y as square difference minus sum difference. Okay, this is done. Okay, now after that we have to solve this equation. Okay, so x plus y is this, and we already know that my x minus y is equal to sum difference. Okay, so now how I'm going to solve this problem? Okay, after this, so this is x plus y, we already know, and x minus y is equal to here sum difference. Okay, this we already know, sum difference. So now here you have to calculate x and y. So x is nothing but a repetitive number. Okay, this is what you need to find, no? And y you need to find. So from this equation I'm going to derive x and y. Okay, so how I'm going to do that? So just add these two statements first. So if I add these two, x plus y, and let's just add it. Okay, here x and here minus y, and here this side square difference divided by sum difference. Okay, and here plus sum difference. Okay, I have added like this. Okay, now here if you see, you are going to cancel out this and this, you are going to get 2x here. So if I take x here and 2 here, so I will get square difference divided by sum difference. Okay, and here you can also take sum difference here as well. Okay, if you want, but you can leave it like this only. Okay, sum difference. So this is how we calculate the sum difference. Okay, x value, x is nothing but square difference divided by sum difference plus sum difference divided by 2. So this is how we are getting x. Now how you are going to get y? So if you want to get y, so just subtract these two, x plus y minus x plus y, and now subtract this minus x, this symbol will be changed to plus. Okay, lot of mathematics. So now this is going to become y, and here we are subtracting x plus y minus x minus y. So here square difference, sum difference, and we have to use minus here. Okay, so square difference and sum difference. Okay, and here minus sum difference. So now you are going to cancel out here x, so it will become 2y. So 2 is going to come downwards, and here we will get y. Okay, so this is the value of y. Okay, that's it. Y is equal to square difference minus divided by sum difference minus sum difference divided by 2. Okay, so this is how we are going to get values. Okay, so I hope that you guys are clear with all the mathematics, right? So what we are doing, right? So now let's see how we are going to write the sum difference first. Okay, sum difference is nothing but this, you already know, right? Sum difference. So sum difference is nothing but the sum that we have, total sum that we are getting from our example 8. And what is my perfect sum? Perfect sum should be 10. Okay, so here I'm just going to subtract this. So 8 minus 10, I will get minus 2. So this is the sum difference. And same way we have to calculate the square difference. Okay, so square difference is nothing but the total square sum that we are getting from our example 18. And what should be the perfect square sum? It should be 30. Okay, so 18 minus 30, so what is the output I'm getting? I'm getting minus 12. Okay, so now we have to apply this same thing here. Okay, so square difference is minus 12, minus this for x now, so minus 12, and some difference is minus 2, and here they are going to cancel out each other, so here I get 6, and in this I am adding the sum difference is nothing but minus 2, so minus 2, and here overall divided by 2, so here I'm getting 6 minus 2, which is nothing but 4 divided by 2, I will get 2. Okay, so yeah, x is the repeating number now, x is the repeating number, and here if you see in my example 2 is repeating. Okay, nice. So now here same way we have to calculate the y, so square difference is minus 12, and some difference is minus 2, and here minus of some difference is minus 2, and here we have 2, so these are going to cancel out each other. 2 6 6 plus 2, okay, minus minus become plus, 6 plus 2 is 8, 8 divided by 2 I will get 4, so 4 is the nothing but y is nothing but missing number, so in this example 4 is the missing number. That's it. Okay, so I hope that you guys are clear with this maths. Okay, so now let's write the code. Okay, so same thing that I explained here, I'm going to write the same thing here. So here first long sum is equal to 0, then take a square sum variable, okay, square sum, and set this to 0 as well. Okay, and n we are going to get the n value as grid dot length, and then after that total. Okay, and I'm going to set total as n into n. Okay, so we are taking n into n, right? Done. Okay, so we have this many numbers, right? Total numbers 1 to n square, right? So that is why. Okay, now we have to calculate the actual sum and the square sum from the grid. Okay, from the example we have to calculate first, not perfect square or perfect sum. I'm calculating the actual sum. So for int row is equal to 0, row is less than n, row plus plus. Okay, and here inside this for int col is equal to 0, col is less than n, col plus plus. Okay, and now inside this what we need to do, we have to write the sum. Okay, so here I'm just going to update my sum as, inside this I'm going to update my sum as sum plus, okay, here grid row, and here col. Okay, now same way I have to update the square sum as square sum plus, and here take it long. Okay, value could be very large. Okay, so here just I have to copy this. Okay, I have to do the square of this now, this into again this one. Okay, and that's it. So this is done. Okay, so this is the way we have to calculate the actual sum and the actual square sum. Okay, this is where my for loop ends. Then we have to calculate the differences from the expected sums. Okay, so here sum difference or square difference. Okay, so long sum difference, and we have to calculate the long square difference. So I have already told you how we are going to do that. Okay, so see here we have derived this now, how I'm going to do that. Okay, so 8 minus 10 we are writing. Okay, 8 is nothing but the actual sum and the perfect sum. Okay, so here what is the actual sum? So that is nothing but sum, and from this I have to subtract the perfect sum. So perfect sum, there is one formula, right? So n square, okay, into n square plus 1. Okay, this was the formula, right? And we have to divide it with 2. Okay, so instead of creating variable, so I'm writing the formula itself here. Okay, divide this with 2. Okay, total into total plus 1 and divide by 2. Okay, so here instead of saying it as n square, I'm saying it as total. Okay, total into total plus 1 divided by 2. Okay, same way here, total plus 1, 2 into total plus 1 divided by 6. Okay, so here square sum minus here same thing, total into total plus 1 into 2 into total plus 1. Okay, and this complete, it should be divided by 6. That's it. Okay, done. Now done. Okay, now we have to we have to use math. Okay, so if x is repeated and y is missing, so we already know that sum difference is x minus y and square difference is x square minus y square. So here just calculate the repeat and missing. Now repeat, here I'm calculating and here I'm calculating the missing. Okay, so repeat, how we are going to calculate. So I'm just going to change it to int because return type is int, right? And here the formula that I have derived here. So this formula I'm going to write: square difference, sum plus sum difference divided by 2. Okay, for x and for y, same formula I'm going to write. Okay, so here square difference divided by sum difference plus sum difference and overall divided with 2. Okay, now same thing here, copy this and paste it here, and now instead of this plus we have to write minus here. Okay, and everything else will be same, right? And then after this we have just return our output, that is not but array type. Okay, new int, and in the array what are the two things that we are passing? We are passing a repeat and we are passing missing then. Okay, done. Now let's run it. So the test case has been accepted, right? And now let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be of n square only, because we are running this loop 2 times. Okay, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.